Hi there, in the last video I explained the change of sign rule. Okay, so let me just quickly go through the change of sign rule. If you're given fx equals 0 and if the function f of x is continuous, so continuous means no breaks in the function, and if you're given an interval ab, if you calculate f of a and if the value is negative, and if you calculate f of b if the value is positive, or vice versa, the other way round, okay, so in other words, if there's a change of sign, that means that there's a root in the interval, so that means that there's a root in your given interval, okay. And I also explained an exception to the change of sign rule also, okay. So let me take an example, so let me take a couple of examples in order to show you how this change of sign rule works. So here's example 1. So example 1 is to show that, the equation e to the x is equal to 4 minus x has a root between x is equal to 1 and x is equal to 2. Okay, so let me show you how the change of sign rule works here. So we're given an interval, so we're given 2x values, so our root we need to prove lies between x equals 1 and x equals 2, and we have the equation e to the x equals 4 minus x. Okay, now in order to use the change of sign rule, we need to make this equation in the form fx equals 0. So I'm going to call that step number 1. So step number 1, let me write down the step in red. So make your equation as fx is equal to 0. Okay, so let me show you what I mean. So I have e to the x equals 4 minus x. So this simply means bring all of your terms to one side of your equation, making the other side 0. So if I bring these two terms to the left, I have e to the x minus 4 plus x is equal to 0. So this term on the left is f of x. Okay, so in this case, let me make a note. F of x is e to the x minus 4 plus x. You could just as well take the e to the x to the right hand side and call that expression f of x. Okay, now in step number 2, so remember the change of sign rule states we need to calculate f of the values and check whether there's a change of sign. Okay, so we have 2x values, x equals 1, x equals 2. So firstly, let me work out f of 1. So if I replace the x's by 1's here, I'm going to have e to the 1 minus 4 plus x, which is 1. And if we calculate f of 2, if I replace the x's by 2's, I'm going to have e to the power 2 minus 4 plus x, which is 2. Okay, now if we calculate those values, so for f of 1 I had something like minus 0.282, so minus 0.282. okay, so as it's negative it's less than 0 of course, and for f of 2 I worked it out to be 5.39. okay, and as you can see it's plus 5.39, that being greater than 0. okay, so remember, if you go back to the change of sign rule, if you do have a sign change, that implies that a root exists in the interval. Okay, so just to close, we have a sign change happening here, so f of 1 is less than 0, f of 2 is greater than 0. So since f of 1 is less than 0 and f of 2 is greater than 0, therefore a root exists between x equals 1 and x equals 2. Okay, so that completes that example. So there's only a couple of steps involved when applying the change of sign rule. Okay, right, I think it's time for another example. So here's example number 2. So let's take a red pen, underline this. So let's show that the equation, sin x that is equal to minus x plus 1 has a root between x is equal to 0.5 and x is equal to 1. Okay? So let's go through step number 1. So remember, let me go back to the previous example. The first step is to make your equation as fx equals 0. So that means bring all of your terms to one side. So if we go back to the equation that we have, so we have sin x that is equal to minus x plus 1. So if I bring these two terms from the right to the left hand side, I'm going to have sin x plus x minus 1 is equal to 0. So this term on the left, I'm taking that as my f of x. Okay, so let me make a note. F of x is sin x plus x minus 1. Okay, so that completes step 1. Let's move to step 2. Now in step 2, as we've done in a previous example, we need to calculate f of both x values given. Okay, and we need to note whether there's a sign change taking place. Okay, now whenever you have a trigonometric function, okay, I would keep the mode of the calculator in radian mode. So whenever there's a trigonometric function present, keep the mode of your calculator in radian mode. Okay, so you can check with me. Let me first calculate f of 0.5. So if I calculate f of 0.5, replacing the x's here by 0.5, we'll have sine 0.5 plus x, that is 0.5 minus 1. Okay, and provided that you have your calculator in radian mode, the answer should be minus 0.02. Okay, and that is negative, of course, so it's less than 0. Let me calculate f of the remaining x value being 1. So if I replace the x's by 1's, I'll have sine x, which is 1, plus 1 minus 1. Okay, and again, provided that your calculator is in radian mode, you should have 0.84, which is greater than 0, so it's positive, of course. Okay, so like with the previous example, you do have a change of sign. That implies that a root exists in the given interval. So over here, f of 0.5 was negative, f of 1 is positive. That implies that a root exists between x equals, okay, 0.5 and x equals 1. So let's close this example. So since f of 0.5 is less than 0, and since f of 1 is greater than 0, so therefore a root exists between x equals 0.5 and x is equal to 1. So that completes that example. Okay, so here are the steps So those are the steps for the change of sign rule, okay? And that completes the video also, okay? So I hope you found this video helpful. Do related practice questions, and I hope to see you in the next video. Thank you.